going to talk about quadratic functions, which you should have covered last year. But these are some things that come up a lot in the standardized testing, and you are going to be expected to know how to do them in your remaining math classes. And so I want to go through, there's 3 forms that you'll find a quadratic function written in. And I'm going to change this word here to general. Okay, so the first, there's general form, vertex form, and intercept form. 3 different ways to express quadratic functions. Now, quadratic functions means that the power of x is a 2. So the general form looks like this. If it's just written in expanded form, so everything's expanded out, there's no grouping symbols at all, okay, this is your general form. Okay, so this corresponds to the command to expand your polynomial. So it takes it from factored form into this expanded form. Okay, vertex form looks like the following. Vertex form has that same leading coefficient, but it's going to be expressed as the form x minus h squared plus k. So this form deals more with the transformation rules that apply. Okay, so h is a horizontal shift, k is a vertical shift, and a is a compression factor when you get into like what the parts of this formula do, all based on what the parent function of a quadratic, which is a U shape. Okay, and so in order to work with vertex forms, we're going to be talking about completing the square, which we'll go over, so you don't have to specifically remember how to do it. We'll talk about it. And then the final form that you might see with quadratic functions is going to be intercept form. It'll still have that same leading coefficient a, but this would be written as factors. And the factors are x minus p times x minus q. You won't always be able to write a polynomial or quadratic function in this intercept form or this factored form. And again, the command for this will be factoring. All right, so I want you to see if you can expand what's given here. So notice we're taking this vertex form, and it wants it to be written in, and again, we'll call that general form. And can you expand that out and write your expression? So I want you to try that. Expand this by hand using binomial squares. We've talked about those patterns. Okay, or you can actually FOIL it out, but see if you can write what that expanded form, that general form, would look like. All right, when you are expanding polynomials in this case, you have this binomial square, and what's going to happen is, I'll write it down below here, the -3 is just going to remain a multiplier. I'll keep that out front, and I'm going to apply the binomial square rules for x minus 3 times x minus 3. And so if you need to FOIL it out, if you need to physically write x minus 3 times x minus 3, you can do that. But the pattern for this, and hopefully you are familiar with that, is when you take a binomial square, we square the first term, so x squared. We take the product of these 2 terms and double it. So x times a -3 doubled is -6x. And then we take our last term and square it. -3 quantity squared is +9. This 12 still stays on the outside. Okay, so that's the first step in solving this. The second step in this is to go ahead and continue to expand, get rid of our grouping symbols. So we'll distribute that -3 through. So we get -3x squared, minus and minus becomes plus 18x. Continue to distribute, we get -27, and then this plus 12. And so the final step is to combine your like terms, and that's going to give us our answer, -3x squared plus 18x. Nothing to combine with those, but -27 plus 12 leaves you with -15. So this would be your expanded form, giving you the general form of that equation. Okay. All right, I'm going to walk you through this next one because, again, it's probably been a while if you have been taught this method. I'm going to talk through it as if you haven't been taught yet. Okay, so even if you haven't, this will be the first time you see it. That's fine. I'm going to walk you through it. Okay, but another way that you can, or one of the ways that you can rewrite an equation if it's given in that general form and you want to put it into the vertex form, okay, is to use what's called completing the square. And so this would be the process for completing the square. You're going to factor out the leading coefficient. Okay, so here we're going to take out the -4. And you're only going to take it out of the first two terms. Okay, so we're left with an x squared and a minus 2x. Okay, so we're removing the leading coefficient from the terms that contain x in them. Okay, now this +1 is still going to stay out here on the outside of the grouping symbols. Okay, once we do this, we're then going to complete the square. Okay, have we talked about completing the square yet? Have we done any examples of that in the previous algebra stuff? Okay. So when you complete the square, here's the steps that you go through. Step 1, you take half of your first degree term's coefficient. And so our first degree term's coefficient is -2. I'm going to take half of that. So half of -2 is -1. Notice where I write it. I put it inside its, like, and again, you don't have to do this, and other teachers don't do this. This is just how I organize the material. Okay, but I'm going to take that number, half of that first degree term's coefficient, which is -1. I'm going to put it in its own set of grouping symbols, including the sign. You're then going to square it. So I'm going to square -1, and you're going to add it. And when you add this to the equation, you have to balance the equation. So when I add this here, so I'm going to put a plus symbol in front. So what I put in, what's written in red right here is something that wasn't on the original equation. -1 squared is 1. I'm adding 1 into that grouping symbol. Okay, so that was something I added to this equation that wasn't there to start with. But it's not really just the +1 that I'm adding here, right? It's +1 times the leading coefficient, which is -4. So really what I did in red that wasn't in this equation before is I put in a -4. So how do I balance my equation if I have a -4 there? I can either go to the other side of the equation and put the same value. So I can subtract 4 from the left side, which doesn't, since I'm not working with the left side, I'm not going to do that. Or I can balance a -4 by adding 4 to the same side of the equation. So what I'm going to do is I'm going to go to the outside here, and I'm going to balance the equation by undoing whatever that value that I added was. So if I put in a -1 squared, which is 1, times a -4, so I actually put in a -4 that wasn't there. So to balance a -4, I need to put in a +4 to maintain that balance. Okay, so that's what those steps represent. And once I get to that step, I'm going to put step 3 over here. Okay, actually I can put it over here. What I can then do is I can rewrite as a binomial square. The whole point of completing the square is that I can rewrite this left side here, or this grouping, as x minus 1 quantity squared, where that second term of my binomial, the x minus 1, is what I did in the very first step of step 2. It's half of that first degree term's coefficient. So that's why I kept it a -1 in the grouping symbols, is I'm going to just take whatever that number is, and that's the term of my, the second term of my binomial. I'm going to combine my terms here. 1 plus 4 gives me 5. And notice this is my vertex form. -4 times x minus 1 squared plus 5. Okay, now, here's the advantage, or here's the benefit to being able to write something in vertex form. And we'll talk about this, I think, in the next slides. and we'll do the next slide or next class. But the vertex in vertex form is just the point HK. It's the horizontal shift followed by the vertical shift. Right? And so by having an equation written in vertex form, it gives you a really easy way to find what the vertex of that U-shaped parabola is. Okay? And so that is the process of completing the square. Okay. We'll come back. I'll talk about that a little bit later or in the next set of the notes that we go through here. The final thing to look at is this last part of how do you write something in intercept form. And the way that you're going to do that is you're just going to factor it. Okay. So again, if I take a look at this expression right here, and I try to factor, always start off by seeing, are there any common factors you can remove from all of the terms? Well, -3, +6, and +45, the numbers of these are all factors of 3. So I'm going to take out the -3, and that leaves me with an x squared, a -2x, and a -5. And then I'm just going to see, can I continue to reverse FOIL this and remove any other common factors? What two factors of -5 have a total sum of -2? Or not 5, sorry, this is a 15. So when I take out a -3 from 45, I'm left with a -15. And so when I look at my factors here, what are the factors of -15 whose sum is -2? -5, +3, there are my factors. Okay, and so this is my intercept form. All right, so that is the process that you're looking at when you are rewriting these different forms of a quadratic function. Okay, the benefit of intercept form is that these points P0 and Q0 are going to be x-intercepts of the graph. And from the general form, the easiest thing to kind of pull out from this is that the y-intercept for this is going to be the point 0, C. So I'll go back at the end of the notes here today, and we'll go over, I mentioned to you before that there's a secondary way that you can find a vertex form for an equation that's written in general form. Okay, but I do want to kind of move forward here. We'll go through the rest of these notes, and then I'll come back and address that with whatever time that we have. All right, so again, I'm going to call this general form. When you look at this, the quadratic function, this form for a quadratic function is called general form. As a polynomial, it's called standard form. So again, you'll see it in both. If you see it, like that's what it represents. Okay, so one of the things that you're going to be asked to do on your standardized testing is to find a vertex of a parabola in one of these 3 forms. Okay, and there's a different process you use for each one. So the idea is not that you need to convert to one form because you only know the pattern for one form. The idea is that you can do it in any of these 3 forms. Okay, so let's take a look at how to find the vertex of a parabola using general form. So once again, general form is just ax squared plus bx plus c. And the way that you find the vertex in this form is to use the following. So b is the first degree term's coefficient. So you're going to take -b over 2a, and that's going to be the x-coordinate of your vertex. Now, if you recall this from quadratic formula, okay, so this is quadratic formula for solving equations. The x-coordinate of the vertex is just this first part. Right? It's that first term, the term that's not going to be, that has no chance of being irrational. That is the x-coordinate of your vertex from general form. And then to find the corresponding y value, what you would do is you would take whatever that number is, whatever the -b over 2a is, and you're going to evaluate that back in the original function. Okay, so you plug that in to the original function, find out what the corresponding value is, and that's your y coordinate. And so without me going through the example, just the notes for this, what I want you to do is see if you can find the vertex for this function that's written in general form. So see if you can follow those patterns, negative b over 2a, and then evaluate the function for that number to get your x and y coordinate. All right, so the equation's already written in general form. We're going to take our negative b value, so b is 7, right? This is our b value, over 2a, our a value is negative 9. And we're going to simplify what we have right here. So the signs cancel, and we get 7 over 18. So that is our x coordinate. Now, in order for us to find our y coordinate, what we need to do is we need to plug this back into the function. Now, I'm going to show you that this is like on the higher end of being challenging. So when we evaluate f of 7 over 18, these aren't going to be necessarily simple to use values. When I evaluate functions, I first write out the sort of the template of the function with placeholders. So I'm going to use parentheses everywhere there's an x. I'm then going to substitute in the value, the fraction, or in this case 7 over 18 for each of these x's, and then I'm going to multiply across. So when I multiply through here, I get negative 9 times 7 squared, which is 49. 18 squared is 324. I'll use a calculator for that. On the second, 7 times 7 is 49 over 18, and then minus 2. So I continue to work here. And I'm going to simplify. The 9 goes into 324, leaving 36. And so this allows me to find my common denominator between 36, 18, and this unwritten 1 is 36. So I'm going to express everything in terms of 36. So negative 49 over 36. What would I have to multiply the top and bottom by on this second fraction to get 36 in the denominator? 2, right? So I get 49 times 2, which is 98 over 36. And then what would I have to multiply this negative 2 by to get a 36 in the denominator? 36 over 36. So I get 2 times 36, which is 72 over 36. And so this gives me my total. When I add all of these together, I get negative 23 over 36 as my y value. Okay, so if that is not something that you want to do and you get this fraction form, and it's not, right? I wouldn't want to do this. Okay, what you can do is you can enter your answer as a calculation, right? And so if we take this whole expression right here, and we enter that as our y coordinate, just enter that whole calculation. And you just have to be careful with it. Make sure you put things in the grouping symbols that you need. But you will get the same answer, negative 23 over 36. So you can either enter your answer as a calculation or as the actual calculated value to get your solution. All right. Finding the vertex in vertex form, super easy. Okay. Remember, vertex form looks like this. This has the same coefficient, leading coefficient a, x minus h quantity squared plus k. And the whole point of completing the square and rewriting it and putting it into this form is that you're using the transformation rules of a shifted parent function to identify this. So the vertex is going to be hk. Okay, so if you have something written in vertex form, it's a really simple interpretation. Okay, your x coordinate is whatever value of x gives you a 0 inside the grouping symbols. Okay, that's your horizontal shift. And your y coordinate for the vertex is whatever number is outside your function. That's the vertical shift. Okay, so I want you to write what you think that answer is based on what I just said. Okay, and I'll kind of reveal it here in just a moment. All right, so what value of x gives you a 0 in the grouping symbols? 6. And what's the value that's outside your grouping symbols? -1. So there is your answer. Okay, vertex form, obviously, I'd mentioned before. Like the easiest piece of information to take away from it is the vertex. And then the last form is if you're given something in intercept form where it's already factored. So that's going to look like the following. Again, leading coefficient of A factored out. X minus P and X minus Q are your factors. And when you find the vertex for these, it's based on the following pattern. I'm going to kind of talk through it here first. When you have a parabola, whether it opens up or whether it opens down, the vertex is the point where this graph is mirrored across. And so the graph is the same on each side of the vertex. And so what that means is when you look at this distance from the x-intercept to where the vertex lies, those are the same. These two distances here and here are the same. And so you're using the idea that the parabola is symmetric to identify that when you calculate the vertex, you calculate it by taking the average of P and Q. That's your x-coordinate for your vertex. And then your corresponding y-coordinate is solved the same way we did in the top problem. You're going to take your original function, plug in whatever that x-coordinate is, and that's going to be your corresponding y-coordinate. Okay, so this would be the pattern for your vertex given the intercept form. Okay, so I want you to see again, like without me like talking you through it yet, see if you can solve this last one based on the factored form right there. Identify what is the x and y coordinate of your vertex. All right, when you're finding the P and the Q value, these are the values of x that give you zeros inside the grouping symbols again. So what would our P value be? What can x be to give you 0 here? -4, and what would x be in the second factor? -9. So there's our P and Q value for these. And so what we're going to do is we're going to take the sum of those, divide by 2. That's going to give us the x coordinate. So -13/2 is the first part of this. And then the second part, we plug that into the function. So we then evaluate f of -13/2, same way that we did up top. We take our original function. All the x's are just placeholders. And so if we plug in -13/2 for each of those, we get our answer. Okay, and so simplifying what we're looking at here, 4 in terms of halves is 8/2. 9 in terms of halves is 18/2. So if I think of those in terms of the same fraction, it allows me to write -13 plus 8 is -5/2. -13 plus 18 is +5/2. 2 and 2 are 4. Go in and cancel with this 4. So that leaves -5 times -5, which is -25. So I get my answer that way. Once again, I could have also entered my answer as a calculation here. Whichever one works for you is fine. Okay. All right. So that is finding the vertex based on whatever form you're given for your quadratic function. Okay. All right. So the next 3 questions are what you're going to be asked to do, or actually, let's talk about the vertex form first. So we have a few questions about vertex form, but the majority of what you're going to be doing is what you see right here on the right, is to sketch a graph and identify all the information about your quadratic based on the form that it comes in. Before we get to that, though, let's look at the quadratic function once again in vertex form. is f of x equals some leading coefficient, x minus h squared plus k. And when you look at this, the a value is called a compression factor. If a, regardless of its sign, is a number greater than 1, then it stretches the graph. Your basic graph looks like this. This is your parent function graph for a quadratic. And so an a that's greater than 1 stretches that, makes it steeper. A value that's less than 1, so a fraction between 0 and 1, makes it flatter or wider. And then that's the compression part of it. And the reflection part is if a is positive, it opens up. If a is negative, it opens down. Okay, the k or the h value is your horizontal shift. So again, the value of x that makes that a 0 is your shift. So if it's a 6 that makes that whole factor 0, then it shifts positive 6 to the right. If it's a negative 6, it'll shift to the left. And then finally, the k value is your vertical shift. If k is a positive number, it shifts up. If k is a negative number, it shifts down. Okay, so based on what I just talked about, like here in those, I want you to see if you can answer this question right below. Okay, what is the shifting that happens based on what you see in this vertex form, the h and k values? All right, so what value of x gives you a 0 inside your factor, inside that parentheses? Positive 4. That means its vertical or horizontal shift is 4 to the right. So we know that it's going to be 4 units to the right. Okay, and then our vertical shift, negative 9, means that it's going down 9. So we get our answer to be that 4 units to the right, 9 units down as your shifting. And so the vertex form is just applying the transformation rules that happen when we talked about the different translations, right? The sliding or shifting. All right, for the most part, what you're going to be asked to do is what you see right here. You're going to be given a function written in one of those 3 forms. You're going to be asked questions about it, and you're going to be asked to sketch the graph of it. Okay, so what I want you to do is I want you just really quickly to see if you can find, well, let's first find the vertex. So go ahead and see if you can find the vertex based on what form they give you. All right, so our vertex, this is vertex form. So our vertex is what value of x gives you a 0 in here? Negative 4, and then what's our y coordinate of the vertex? The horizontal or the vertical shift, negative 1. So here's where our vertex lies. When you sketch the graph, you're going to select your graphing utility. Notice it has 2 points. You need to plot 2 points to sketch this. The very first point is going to be the vertex. So we sketch negative 4, negative 1. So we're going to plot that point first. So you're going to find your vertex, and then you're going to plot it. What you then need to do is plot a second point. The easiest way to find the second point is to add or subtract 1 from the vertex. Okay, and so here, if my vertex is negative 4, the easiest thing to do is to just plug in a negative 3. Notice I'm going to evaluate my function, y of negative 3. So I take my function x plus 4 squared minus 1. My placeholder here, I'm going to fill in the negative 3. And when I do that, I get 1 squared minus 1, which gives me 0. So negative 3, 0 is the point that I plot. So once I plot this second point, your graph's going to fill in for you. Okay, so the first step here, find your vertex, plot it, find a second point by moving 1 to the right, 1 to the left. If there happens to be a coefficient in front of your expression right here, instead of being 1 plus or minus 1 from the vertex, I would add or subtract a number that makes this equal to the denominator of that fraction. You don't want fractions if you can help it. So pick a number to test that's going to give you integer values. Okay, then you can find your y-intercept. So think about what it takes to find your y-intercept. A y-intercept has an x-coordinate of what? 0, right? So you're going to take your function and you're going to evaluate it for 0. So we take y of 0, which is our x is a placeholder, plus 4 squared minus 1. Plug in a 0 and evaluate. 0 plus 4 squared minus 1, that gives you 16 minus 1, or 15. So notice your y-intercept is an ordered pair. Now, that y-intercept's not going to show up on your graph, so you do need to be able to calculate this without using the graph itself. Now, the x-intercepts, here you actually see where your two x-intercepts are, so you could just plot these points. Or, sorry, not plot them, but list them. So -5, 0, and -3, 0. However, you won't always be able to do that. If you need to find your x-intercepts, what you're going to do is take your original function and set it equal to 0. So if we replace the y with the 0 and then solve, okay, what we do is add 1 to both sides, extract your root. When you extract the root, you have to take into consideration both the positive and negative root. Subtract 4 from both sides, and that gives you x is -4 plus 1, which is -3, -4 minus 1, which is -5. So those would be your two answers. Okay, but if you can use the graph, that'll save you a little bit of time. Right, and then these last 3 questions are ones that, again, if you just rely on the graph, you should be able to answer. Okay. What is the domain of a function? Have we discussed that? Have we discussed that this year? The domain is the inputs, which can also be the x-coordinates. Okay, so is there any limit to what your domain is? Any limit to what the x's are? X can be anything. So your answer, you're going to write it as an interval, and the interval is -infinity to +infinity. Have we discussed how to enter infinity on the system? Okay, so in the drop-down, you can see infinities, but you can also label them with the 2 consecutive lowercase o's. And so if you type in parentheses -00, comma, 00, parentheses, it will turn that into the infinities for you. Okay, or you can use the drop-down in the equation editor. Okay, what about range? Range is the outputs, which are the y's. So what is the limit on the range? When you use intervals, you use the lowest limit first. So what's the lowest y value of this graph? It's a value of what? -1. So we're going to start with -1. And is there any limit to how high it goes? No, the arrow tells you it keeps going up. So that's infinity. You always use parentheses on the infinities with the interval notation. Anytime a number is included, like it is right here with -1, you're going to use a square bracket. Okay, and the square bracket is just a key. It's its own key on the keyboard. All right, the final question here is the equation of the axis of symmetry. We talked about this in the previous slide, that a parabola is symmetric to a vertical line through its vertex. And so the equation for the axis of symmetry will always be x equals whatever the h value, the x-coordinate of your vertex, which for us is, or for this problem, -4. And so these would be the answers that you would find for a question like this. Okay, now, this same set of questions is going to be asked for standard form or the general form as well as for intercept form. Okay, so let's take a look at how you would answer each of those. All right, so standard form once again, or the general form here. Okay, so when you're looking at general form, you have your vertex, which is negative b over 2a, and then you evaluate your function there. You have your y-intercept, where it's 0, whatever the c value is. And so those are what you're going to see when you're looking at this. Okay, so you still need to follow the same instructions from the last set. Find your vertex first. Plot it. Okay, you're then going to select a second point. For this, the best second point to plot would be your y-intercept. That would give you your graph. And then you can solve for the remaining answers either by looking at the graph, okay, or applying the properties. And so see how far you can get here in the next couple minutes. If you have not figured out yet in this class, my philosophy on learning is repeat things as much as you need to until it makes sense to you. Okay? Now, if you don't understand it and you don't follow, if you can't follow what the detailed solutions are, doesn't mean that you should give up. It means that you need to kind of go to the next step of understanding, which is asking a question. So either ask me or somebody that you think understands it and can explain it. Okay, but if you don't get this, and even if I go through this example and you still don't get it when it comes time to do the homework problems, try it multiple times until you get it figured out. If you need to go over a problem with me, then that is something that is your responsibility. Okay? Come in, ask me, we can go through it, and hopefully it will start to make sense to you. All right, so let's look at how we would complete this problem. So the first thing is we need to find the vertex. Well, the vertex is given in general form, so we need to take our negative b over 2a form. So here's my b value, so negative a negative 2 over 2 times my a value is negative 1. The negative sign, one of them cancels. I'm left with a negative 2 over 2 cancels, so this is a negative 1. So my x-coordinate for the vertex is negative 1. My y-coordinate, I'm going to take my y function, substitute in a negative 1 to all the x's. So if I write that out, use placeholders here, and then plug in my number, negative 1, into each of these placeholders, I get negative 1 squared as a plus 1 times a negative 1 gives me negative 1. Minus 2 times minus 1 gives me a plus 2, plus 3. And so if I evaluate this, 2 and 3 is 5, minus 1 is 4. So there's my y-coordinate. So I'm going to first select my graphing utility, plot the point, negative 1, 4. So there's my first point. Okay, next, I'm going to plot a second point. Now, for me, the easiest second point to plot, because this is given in the general form, is my y-intercept. My y-intercept is the point 0, whatever my constant is, 3. And so if I plot that as my second point, it will complete this graph for me. All right, so again, the graphing utility will finish this graph for you. Next, find your x-intercepts. If you're lucky, you will see them from your graph. Okay, and so here you would see these two x-intercepts, and so you would know that you're dealing with 1, 0 and negative 3, 0. But if you didn't know, what you would need to do is you would need to plug in a 0 for your y value and then solve the resulting function or solve the resulting equation. Here I would multiply both sides by a negative 1 to get rid of my leading coefficient that's negative, changing the signs. And then I try solving by factoring. the two factors of -3 whose sum is a +2 are +3 and -1, which gives me -3 and +1. I'd get my same values here even if I had to solve by factoring. Okay, so if I go back in, let's see, I'll answer these questions. So -1, 4 is my vertex. My y-intercept is 0, 3. My x-intercepts are 1, 0, and -3, 0. My domain, are there any restrictions to my x values? No. And for any polynomial, that will be all real numbers. So -infinity to infinity with parentheses. Now my range, though, is limited. This time, since my graph opens down, the limiting value is my upper value. I have a maximum here. So when I write my intervals, I start with the lower value first. Is there any limit to how low this goes? No, so -infinity with a parentheses. Okay, but the highest value of my y's is right here, and what is that number? 4, and there's a bracket there because it does include that 4. So there's a bracket at the 4. Okay, and then my axis of symmetry is going to be a vertical line that passes through my vertex. So it's always in the form x equals, and whatever that x-coordinate of the vertex is. So the x-coordinate of the vertex is -1. So these would be my answers to the rest of this question. All right, one last form, and that is the intercept form. So on the next slide, I want you to see, can you do the same thing, but with the intercept form? Can you find the answers to all of these elements and sketch your graph based on what you're given? And again, the intercept form is x minus p times x minus q. And here, the advantage is you see what these points are, the x and y intercepts. Okay, and then your vertex, once again, is the average of those. And then whatever the corresponding y value is for that. Okay, so see if you can answer all of those questions for this function. All right, so step 1, find your vertex. We have our pattern for the vertex over here is the zeros for each of these factors. So what 0 corresponds to the factor x plus 3? The value of x that gives you a 0 inside that factor is -3. And for the second factor, it would be -1. So when we calculate this, we're going to take -3 plus a -1 over 2. There's our x-coordinate, which is -4/2 or -2. And then we plug that into our function and evaluate the result. So if I take y of -2, I get x plus 3 times x plus 1. I'm going to leave a space here as a placeholder, plug in my -2 in each of those, and that gives me a +1 and a -1. So my y-coordinate is going to be, in this case, -1. So there's my first step. My vertex is -2, -1. I will plot this point, so select my graphing utility, -2, -1. Okay, now I see that my, going to plot a second point. When I plot this second point, in this form, the easiest second point to plot is going to be an x-intercept, right? Choose either of my x-intercepts. For me, I can choose either -3, 0 or -1, 0. Okay, and so I'm going to choose -3, 0 right here. It will fill in my graph. If I had chosen this one, it would do the same thing. So either of those would work. That allows me, or that is my x-intercept, so I'll go ahead and plot these, or I'll fill these in. Okay, I do need to find my y-intercept. Now, if I were to sketch this correctly, I would have seen my y-intercept more carefully. Let me kind of sketch what this would look like a little bit more carefully. would look like this. And so I would be able to see where my y-intercept was, and so I could answer it 0, 3. But if I can't, the way that you find your y-intercept is you evaluate your function for 0. Right? The y-intercept is the y value when x is 0. So if we take our function, leave the x's as a placeholder, and fill it in with this number 0, I get 3 times 1, which is 3, and that is the y-intercept. Okay, domain is all real numbers. The range, again, here we do have a limiting value. The lower value is the limiting value, so we start with the lower value, -1. It is a bracket there, and there is no limit to how high this graph goes. It continues infinitely. And then finally, the equation for my axis of symmetry is this vertical line through my vertex. Vertical line is represented as x equals, and I just plot that number, which in this case is the x-coordinate of my vertex, -2. And so this is how to write equations if you're given the quadratic graph, or the graph of a quadratic. Okay, so the first step is to identify the coordinates of your vertex. And so when you look at the graph here, you're simply going to identify what are the coordinates for this vertex. Well, here we see that it is -2 for the x-coordinate, +5 for the y-coordinate. So that is step 1. Step 2, once you find this, what you're going to do is you're going to plug in the given point. So that's the x and the y that's given. Again, that's down here, or it's located here, again, depending on whether it fits on the graph or not. Okay, you're going to plug in the coordinates for those points and your vertex. Remember, the vertex is hk, into the equation for, I'll use function notation, the equation for vertex form. A times x minus h squared plus k. This is going to allow you to solve for a. Right, so the next step here is we take our basic equation, f of x is equal to a times x minus h squared plus k. We're substituting in the x and the y value. We're substituting in the h and the k value, and we're going to solve for a, right? So our y value is 17. Our a remains unknown. That's what we're solving for. Our x value is 4. Our h value is -2. And our k value is 5. So these are the pieces that we're plugging in. Minus minus is a plus. So here we get 17 is equal to a times 4 plus 2 is 6 squared plus 5. Subtract 5 from both sides. That leaves 12 equals a times 6 squared, which is 36. Divide by 36, and we get our a value to reduce to be 12 goes into 36 3 times. So we get a is 1/3. Once we get our a value, we're then going to write the equation. Okay, so now we have our a value, we have our h value, we have our k value. So when we write our equation, it's also going to be in this vertex form. So we get f of x is equal to a of 1/3 times x minus our h value of -2 squared plus our k value 5. Okay, and so that would be the equation for that graph. The biggest mistake students have made in the past is they forget to square that binomial. And so make sure you write the square, and don't forget that. That's the most common mistake if you get all of the parts right, but they forget to put the square. Right, so I want you to try these 3 steps with the second equation. The negative signs are going to take care of themselves when you solve for the a value, so you don't even need to worry about it. You should just check it and see, though. 1/3, we were expecting this graph to open up. It's a positive a value. It's a fraction, so there is a compression factor, which means it's a little bit flatter graph, or wider and flatter than it would be if there was a coefficient of 1. That's also pretty consistent with what you see up there. It is a little bit wider. Bless you. So looking at the graph, you should see that this is a little bit wider graph. That means that the fraction is going to be between 0 and 1, less than 1. It also opens down, so you should expect that your a value, or the leading coefficient, should be a negative number as well. So when you come up with your final value for a, we're expecting it to be a negative fraction less than whatever the absolute value, less than 1. So a number less than 1 and a negative sign. All right, so let's go through these three steps here. So first step, find the vertex. The coordinates of our vertex we see here, x coordinate of 3, y coordinate -4. We have our given point. And so what we're going to do is take our function, f of x equals a times the vertex form, x minus h squared plus k. We're going to plug in our x, our y, our h, and our k. So here's my x, or actually I'll go from left to right. So here's my y, -9. A is unknown. My x is 8 minus my h value of 3 squared plus my k value of -4. And I'm going to solve for my a value here. So I add 4 to both sides. That gives me -5 is equal to a times 8 minus 3 is 5 squared. I'm going to divide both sides by 5 squared, which is 25. And that gives me 1 over 5, so -1/5. Did that fit the conditions I was expecting to see? It's a negative fraction less than whose value is less than 1, or magnitude, so yes. And so I get -1/5 times x minus my x coordinate, or x coordinate of the vertex, 3 squared plus a -4, and there is my solution. And so if completing the square isn't making sense to you, what you can do, since you know that this equation can be written in this form, right? This is the vertex form. If you know what your a value is, and you know what your h and your k value are, you can enter your answer directly. We know our a value. The leading coefficient doesn't change. That's the one thing that doesn't change between all three of those forms. So what I do know is my equation is going to be -4 times x minus h squared plus my k value. And so all I would need to do is find what is my h and my k value, and if I do that, I have my answer. Well, they gave you the equation here in general form, right? How do you find the vertex from general form? You use what? You can use -b over 2a, right? So if we find the vertex by using the form that's specific to the general form, we have our b value of 8, so we get -8 over 2 times our a value is -4. The negative signs cancel. 8 over 8 reduces to 1. So we get an x coordinate of 1. So we can plug our 1 in there. That's the h value. And we can evaluate f of 1 to find our k value. So -4 times x squared plus 8 times x plus 1. Substitute in this 1 to each of these placeholders. And that would give us -4 times 1 plus 8 times 1 plus 1. 8 plus 1 is 9. 9 minus 4 is 5. So that's our y value. And notice we get the exact same thing if we just use the methods to find the vertex and plug it straight in to that equation.